Hello everyone, welcome back to another episode of Solving LeetCode Hard Questions. Today's question is IPO. The question is a little long, but let's read through it together. Suppose LeetCode will start its IPO soon. In order to sell a good price of its shares to venture capital, LeetCode would like to work on some projects to increase its capital before the IPO. Since it has limited resources, it can only finish at most K distinct projects before the IPO. Help LeetCode design the best way to maximize its total capital after finishing at most K distinct projects. For input, you're given N projects where the ith project has a pure profit I, and a minimum capital of capital I that is needed to start it. Initially, you have W capital. When you finish a project, you obtain its pure profit, and the profit will be added to your total capital. Pick a list of at most K distinct projects from the given projects to maximize your final capital and return the final maximized capital. So for example, when the input is K equals 2, W equals 0, profit is 1, 2, 3 with their respective capital of 0, 1, 1. Then let's see what the output is. Initially, we start with 0 capital, so there's only one project to choose from, which is project number 1. So we gain a profit of 1. Then with this capital of 1, we can start either of the second or the third project. But because the third project gives us more profit, we'll choose this one. So the total 2 projects we can choose will give us 1 plus 3 equals 4 capital. And the output is 4. How do we solve this? Pause here if you like to think independently for a moment. The key thing to identify here is that this is a greedy problem. We need to always pick the project with the highest profit. However, the amount of capital we have is limited and depends on what projects we choose. So to add on to my previous statement, we should always pick the highest profit that's within our current budget. Using the same example as before, in the first iteration, when we start out with 0 capital, there's only one project to choose from. And in the second iteration, we have more projects to choose from. And between these 2 projects, we choose the project with the highest profit. In summary, we need to couple profit and capital together in a new list, so we know for a project how much capital is needed and how much profit we'll gain. Note that because the profit is always greater than 0, W will always increase. So at every iteration, more items will be available for us to pick from. And from this available items list, we need to return the maximum profit. To get the available items easily, we can sort the projects by the amount of capital needed to start it. And starting from the beginning, we can add them to the available list by comparing it with our current capital. At every iteration, we need to pop out the item with the max profit. So a max heap will be appropriate here. Let's look into this deeper at the next slide. To quickly recap the instructions, first, at every iteration, insert the newly available projects to the max heap and pop from this max heap. And we repeat until K items were picked or there are no available items in this heap. So let's look at this new example where K equals 3. Starting capital is 0. Profit is 1, 2, 3, 4, 3. And the amount of capital needed to start them are 0, 2, 1, 1, 3. So first step, couple profits and capital together and sort them by capital. We obtain this new list. At the first iteration, the starting capital is 0, so there's only one project to choose from. And we gain a profit of 1. So now we have a capital of 1. This means we have 2 more projects to choose from. We add them into this heap and pop the maximum element from the top of the heap. In doing so, we gained a profit of 4. 1 plus 4 equals 5. So now we have a capital of 5, which means we can basically choose all the rest of the projects in this list. So we add them in the heap And again, only pop from the top of the heap, which is the maximum element, and that gives us an extra profit of 3. So the final profit is 1 plus 4 plus 3, which is equal to 8. Putting everything together, this is what the Python code looks like. First, we couple the profits and capital together in a combined list. Then sort this list by the capital. The next step is to run a loop, and we will add to this max heap of projects satisfying the capital requirements. So only when the project capital is less than the current capital will we push to the heap. If there's nothing inside the heap, we can return the current profit right away. Otherwise, we'll pop the maximum profit from the heap and add that to our current capital. And in the end, we'll return the final capital / profit. The final time complexity is O of n log n because sorting is n log n. And for the second half of the block, inserting to the heap is O of log n, and we're doing it for possibly every element, so that's also n log n. And the space complexity is O of n because of the heap size. That's it for today. Thank you for listening, and let me know if you have any questions. See you next time.